1.5, Exploring Angle Pairs. And the objective of this lesson is to identify special angle pairs, and we are going to use their relationships to find angle measures. Our first special angle pair are adjacent angles. What does adjacent mean? Adjacent means next to. If you are adjacent to something, you are next to it. The school is adjacent to the field. Adjacent angles are two coplanar angles, that's important, and they have a common side and a common vertex. Now the important thing here is that they have no common interior points. It means they're next to each other, they don't overlap. They don't overlap. So if we look over here, we can see that we have a couple of angles. Angle 1 and 2 share this common vertex and this common side. And angles 3 and 4 are also adjacent angles. They have a common vertex and a common side. Notice they do not overlap. Next are vertical angles. Vertical angles are going to be extremely special to us. We will give them 3 stars. Vertical angles. Now this definition is a difficult one. Two angles whose sides are opposite rays. Well, what do we know about opposite rays? We know opposite rays make a line. So what I like to think of vertical angles is they are made by intersecting lines. And if we look over here, you can see we have two intersecting lines. And so if we look at our intersection point there, you can see we have two sets of opposite rays. So we have two intersecting lines, and angle 3 and angle 4 are vertical angles, and angles 1 and angle 2 are vertical angles. They are opposite of each other, made by these intersecting lines. And something we are going to put a star with here, and we will get a theorem on this later. Vertical angles are congruent. So you notice here that I marked angle 3 and angle 4 congruent, and I marked angle 1 and angle 2 congruent. Vertical angles are congruent. Next on our list are complementary angles. Complementary angles, you've probably run into these before, are two angles whose measures sum to 90 degrees. These angles are complements of each other. Anything that adds, any two angles that add to 90 degrees, their measures add to 90 degrees, are complements. Now the thing to remember on these is they do not have to be adjacent. They don't have to be next to each other. Now, if we look here, we have angle 1 and angle 2. They are adjacent, but we have a mark here that tells us those are right angles. So we know that those measure 90 degrees. So the sum of the measure of angle 1 plus the sum of the measure of angle 2 would equal 90 degrees. And angle 1 and angle 2 are considered complements of each other. Now let's look at angle A and angle B. 47 plus 43 is 90. These sum to make 90 degrees. So the measure of angle A plus the measure of angle B equals 90 degrees. These two angles are complementary. If you see the word complementary, you know that they sum to 90 degrees. Okay, and supplementary angles. Supplementary angles, the measures sum to 180 degrees. And these angles are supplements. So if we look here, we have a line, angle 3 and angle 4. These are adjacent angles, and they sum to 180 degrees. Now, if we look at angle B plus angle C, 137 plus 43, the measure of angle B plus the measure of angle C are going to equal 180 degrees. Those are supplements. Again, they do not have to be adjacent to be complements or supplements. Let's look at an example. We are said, use the diagram. Is the statement true? So we are asked, angle BFD and angle CFD are adjacent. Well, the first thing we're going to do is go over here to our diagram and identify angle BFD. All right, and then we are going to identify angle CFD. Now, are they adjacent? No. They have a common side ray FD there, and a common vertex F, but they have common interior points, so they are not adjacent. Remember, they can't overlap. All right, angle AFB and angle EFD are vertical angles. Well, let's find angle AFB, and angle EFD, are vertical angles. Well, what do we know about vertical angles? Vertical angles are made by intersecting lines. Are these made by intersecting lines? No. Ray FA and FD are opposite rays, but ray FE and FB are not opposite rays. They are not a line. And the last one here, angle AFE and angle BFC are complementary. Well, I'm going to make a little note to myself here. I know that complementary means that they add up to 90 degrees. So let's find angle AFE. I'm going to mark AFE and BFC. And I look at them, 62 plus 28, that equals 90. So the sum of the angle measures is 90. So yes, they are complementary. All right, pause the video and do the next problems. All right, A says angle AFE and CFD are vertical angles. So if we look over here and identify angles are angles, we see that they are created by intersecting lines, okay, and they're the opposite angles in those intersecting lines. So yes. Part B, angle BFC and angle DFE. So BFC is the blue one with 2 angle marks, and angle DFE is this big one down here. Are they supplementary? We know supplementary means 180 degrees, and 118 plus 28 does not equal 180 degrees, so they are not supplementary. And the last one here, angle BFD and angle AFB are adjacent angles. I marked out my 2 angles there. They have a common vertex and this common side, and they don't overlap, no common interior points. So yes. Now if we look at the names here, look right here. BF and FB, those are the same ray. And F is our vertex, right? Vertex is always in the middle. So you can look at the names and see that they have a common vertex and a common side. And then you can just look at the angles and see if everything else fits, if they are not overlapping, if they are adjacent. So the names are very important and can tell you quite a bit. As you look at your diagrams and think about the naming of these, you'll learn to see that. All right, let's go on. Oh, good stuff here. Good stuff. There are things that we can assume to be true, and most stuff we cannot assume unless we are given it or have something that lets us get to that. So let's look at the things that we can assume to be true on an unmarked diagram. We can identify adjacent angles, okay, because we can see the common vertex and the common side. And we can determine that angles are adjacent and supplementary, because supplementary angles are going to form a line. And that looks like this, which is going to be very important to us. And we can assume that angles are vertical angles. If we have two lines that intersect, we know that vertical angles. It creates vertical angles. So these are very important to us, and we will use them frequently. Things that we cannot conclude from an unmarked diagram. These are things, if it is not given to you in words or in markings on a diagram, you can never assume any of these things. You cannot assume angles or segments are congruent. Just because they look like they're congruent does not mean they are. You can never assume that an angle is a right angle. It may look like a right angle unless it is marked, or unless you are told that it is a right angle, or that lines are perpendicular, so by definition are a right angle. You cannot assume a right angle. And in the same sense, you cannot assume that things are complementary. Now, we said we could assume supplementary, but that's because they make a line. You cannot assume complementary right angles, and especially you cannot assume that things are congruent. Okay, let's look at some examples of this. What can we conclude from the diagram? We can conclude that angle 1 and angle 2 are congruent. How come? Because they're marked. Those markings right there say those two angles are congruent. Simple little markings. We can conclude that angle 3 and angle 5 are vertical angles. Well, of course we can, because we have two intersecting lines. So 3 and 5 are vertical angles. We have entire sets of adjacent angles here. You can go through all of those. Like angle 1 and angle 2 are adjacent, angle 2 and angle 3 are adjacent, 3 and 4 are adjacent. They're angles that are next to each other and have a common side. And this last one here, adjacent supplementary angles. Look at angle 3 and angle 4. There is a line right there, and angle 3 and angle 4 are adjacent angles that make up a line, therefore they are supplementary. And we can see that in angle 4 and 5. As well. We have another line here. I'll mark that one with this line here. So angle 4 and angle 5 are adjacent and supplementary. All right, pause the video, do the next problem. All right, we are asked, segment TW is congruent to segment WV. If we look on our diagram, absolutely, those are marked. We have congruent markings that tell us our segments are congruent. So yes, all of the rest of these are no. We cannot say that PW is congruent to WQ. There are no markings. We cannot assume congruent. This looks like a right angle. We cannot assume any of these are right angles. None of these are marked. Now let's look at D. Let's look at it very carefully here. It says segment TV, this segment right here, bisects segment PQ. That is not true. We cannot say that because there are no markings on PQ. But let's look at it the other way around. Segment PQ bisects segment TV. We know that because we have the congruent markings. And because we have the congruent markings, we also know that point W is the midpoint of segment TV. Remember we said bisect and midpoint and congruent all go together when we're talking about segments? So order matters on these, and you need to learn to read them as PQ is doing an action to, bisect is a verb, okay, and TV, segment TV, is who the action is being done to. So you have to be really careful with that. You will learn to read these. You will learn to look at your diagrams first, and those congruent symbols, they will jump out at you. All right, let's look at the bottom part here. These two things are huge, 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 huge. Okay, a definition here, linear pair. What does linear mean? Linear is just a line, right? A linear pair is a pair of adjacent angles whose non-common sides are opposite rays. And what's an opposite ray mean? Opposite ray means line. The angles of a linear pair form a straight angle. This is 180 degrees. So hopefully you see that and go, they're supplementary. This diagram right here, anytime you're dealing with a linear pair, if you have to draw a linear pair, this is a good, standard, generic linear pair. And you notice I drew it up above when we were talking about angles that were adjacent and supplementary, one of those things that we can assume. We now have a word for this. This is a linear pair. And this takes us to our linear pair postulate. Know this, love this, use it. This one and the vertical angles are going to stay with us until the end of the class. This says, if two angles form a linear pair, so this is the requirement. If we have a linear pair, then the result is they are supplementary. So we can say that the measure of angle A plus the measure of angle B equals 180 degrees. If you have a linear pair, then you can say that they are supplementary. So if we have this, a linear pair, and this is a line, so we know that it measures 180 degrees, that we can add their measures together to equal 180 degrees. This is hugely, hugely, hugely useful to us. All right. Examples. We do enjoy examples. Angle KPL and angle JPL. Oh, look what we see here. I see a common vertex and a common side. You see that when you read that? Are a linear pair. All right, so I know 180 degrees. So I look over here and I find angle KPL, that's my center point, KPL, and angle JPL. Notice I'm not drawing my angles anymore, I'm just putting little angle marks in them. They are not congruent, so I use one angle mark in one and two in the other. So I have found my angles, and the measure of angle KPL is 2x plus 24, so we label that if it's not already labeled. And the measure of angle JPL is 4x plus 36, so we label that if it's not already labeled. And then we want to find the measures of our angles. Well, I know that they are a linear pair. So, first thing I would put on here is angle KPL and angle JPL are supplementary. This is my linear pair postulate because I have two adjacent angles that are supplementary, that form a line, two adjacent angles that form a line. Then I can say that the sum of the measures is 180 degrees by the definition of supplementary. I substitute in, do my math, and I get x equals 20. Now that's not what I was asked for. I was asked to find the measures of the angles. So we substitute back in, and we get the measure of angle KPL is 64 degrees, and the measure of angle JPL is 116 degrees. And if we want to check that, we can just add them together. Carry our ones. Carry our one. Not doing my math very good there. 180 degrees. All right, pause the video and you try it. All right. A was how do you check your results in problem 3? We just did that. We added them together. All right, part B. We're given two angles and we're told they are a linear pair. Notice when I read the angle names here, I see a DB, D is a vertex, and BD, D is the vertex. I know they have a common side. And I'm told that they are a linear pair. So I draw my diagram, draw my linear pair, label my angles, and then I'm given their measurements. So I label the measurements. And I know that through the linear pair postulate that they are supplementary, which means that I can say their angle measures sum to 180. I substitute in, I get x is 21, and then that's not what I'm asked. I'm asked for the measures of the angles, and so I substitute back in, and I get the measure of angle ADB is 77, and the measure of angle BDC is 103 degrees. And if I want to check that, I can sum them together. I just add them up, and yes, they make 180 degrees. Therefore, they are a linear pair. Very nice. All right. We've seen this word before. An angle bisector. What do we think when anytime we see the word bisector? Two congruent parts. So an angle bisector divides an angle into two congruent angles. Now the thing about an angle bisector is that its end point is the angle vertex, and a segment can also be an angle bisector also. So let's look here. I am told that ray AY, so ray AY here, is the angle bisector. Remember, order matters here. Ray AY is bisecting. That's our verb. It is doing something. Who is it doing that to? angle XAZ. Okay, there's our angle that's being bisected. The ray bisects the angle, and as soon as we see that, we know two congruent, this is congruent to this. And when I mark congruent, I like to offset my congruent marks so that they're easier to read, so that you're not thinking, oh, did I just mark a single angle? No, I'm marking these two angles congruent, because that's what bisect tells me. Bisect means two congruent parts. Whether it's a segment or an angle, it's two congruent parts. So let's look at our example of that. We are told that ray AC, let's find ray AC here, bisects angle DAB. So find angle DAB. We're bisecting this angle right here. Bisect, as soon as we see that word, we think two congruent parts. What's being broken up into two congruent parts? Angle DAB. So I'm going to mark this and this. I have two congruent parts. And then we are told that the measure of angle DAC is 58 degrees. What is the measure of angle DAB? Well, this is automatic. Period. End of sentence. Soon as I have congruent marks, if one is 58, the other is 58. And if we were doing a proof, we would say angle DAC, let's put it in the same order they do. Angle CAB is congruent to angle DAC, and this is definition of angle bisector. And then we could say the measures are equal by definition of congruence. We don't go straight to the measures there. And I wish they would do this correctly from the start, because once we get into proofs, they change it to this. They should teach you correctly from the beginning. So our angles are congruent because that is the definition of bisect, right? Bisect tells us two congruent parts. So our angles are congruent, and our measures are congruent by the definition of congruence. Congruence means equal segment length or equal angle measure. And so 58 equals 58. And then we want to know, we are asked, that wasn't what we were asked. We are asked, what is the measure of angle DAB? Well, that's the measure of the whole thing. So we can use our angle addition postulate, add the two of them together, and we get 116 degrees. The measure of angle DAB is 116 degrees. All right, go ahead and do the last example problem there. There's not a lot of room down below, so I might draw my diagram in here. There's a hint for you. You can work with that. All right, so we drew our diagram. We know that ray KM bisects angle JKL. So I drew my big angle JKL, and then I used my ray KM to go down the middle. And I'm told that it bisects, so the first thing I did was marked my two angles congruent. And then I'm told that angle JKL measures 72 degrees. So that is the entire angle. Well, if I don't know my two little angles inside, so I labeled them X. In math, if we don't know something, it's X. We still know what it is. It's X, because X is a number. So I know from angle addition postulate that the measures of my two angles equals the whole angle, so that's 72. But I know from bisect, definition of bisect, that my two angles are congruent, which is why I can label them both x. So I can just say x plus x is 72, and so 2x is 72. I divide by 2 on both sides, and x is just 36 degrees. So if x is 36, then the measure of angle JKM is 36 degrees, as is the measure of angle LKM. So bisecting is way cool. All right, that was fun. This is the end of chapter 1, and we're going to have some fun with our homework.